Hi, this is Scott from KIG. It is December 29th, 2015. We're going to run and test this 5-ton SAC Silver Star Air Cooled Chiller here. It's a 208 230 volt system with a 5-ton Copeland, I'm sorry, 5 horsepower Copeland scroll compressor. We have the side cover here obviously, but we're going to run it in this case with the side cover off, which we can. The manner in which this one is designed, where the condenser is horizontal here. We're just going to go right ahead and power the unit up. This does have phase detection, so when you do first get it, if it goes into the wrong phase, alarm, error 06, you just have to switch any of the two leads. Again, 3-phase power. 208 230 volts, typically a 30 amp circuit is fine. So when this happens, you just press the power up, press the on button, and then the screen comes up here. It is in centigrade. We already went ahead and preheated the water to about 78 or 80 Fahrenheit equivalent, basically 24.5 degrees centigrade. So you press the on button, then you press the pump. And might be a little delay in the pump that you heard, and so then you get water circulating through the system. In this case here, we just made a little simple loop here to run and test. So we've been running it for about a week or so. We had to get a new little sight glass indicator, and we also found some weird wiring thing on a pressure switch, but we fixed that. But that's why we run the heck out of these things. So first thing you do is SV is your set point value, P is the process value. You simply press set, and we're going to bring it down to, we actually put in, usually you can go to 5, but we know this customer is going to run straight water, so we actually locked it at 9. We can give them the passwords to change it, but just for safety, otherwise you can run the risk of freezing water inside the exchanger. So then we just press set. Okay. Then there'll be a little bit of a delay before the compressor turns on. Actually, you want to press compressor after you to get the unit going. So you turn the power on, you press pump, then you press compressor, and then it'll start chilling after that time delay. You can see the time delay there. Usually it's somewhere between 30 and 90 seconds, and that's intentional just so you don't short cycle the unit. We'll ship it with this little key here for the controller, the box, which is just this temperature controller, which does have built-in error codes in it behind the top drawer, and in the bottom as we have the rest of the electrical, the contactors for your fan and pump and compressor. And we have the adjustable, don't change those settings without talking to us, but that is the adjustable pressure switch for the high and low pressure. And then you have your high pressure refrigerant gauge for the R407C and the low pressure. And this is R407C, which is a green type of refrigerant, which most people want for new chillers. This one is slightly used, but you know what I mean. So we have 2 cooling fans on top. They do operate at the same time, and again our condenser underneath here. And you have your pump, which puts out, I don't know, about 20-something GPM. And you have our stainless insulated reservoir tank. And behind the tank, just see in there, is your brazed plate heat exchanger. This here is just a little bypass tube, which gives some additional safety in case your process has solenoid valves on it, and will potentially block the flow in the loop. You probably should have your own secondary bypass also. So you can hear the chiller turned on, both our fans are running here. start chilling fairly rapidly. It should stop right at the set point. Got a little bit of glare here, sorry about that. Should stop right at the set point, and then it'll wait to go about 1 degree centigrade above before it turns back on again. If needed, we can give the customer the passwords to go in and change that, but we find that works best for nearly all applications. This is an indoor unit. It should be inside a facility. Really don't want it any colder than 50 or 55 Fahrenheit. And you definitely really don't want to run these units in a building where it's going to get up over 95 Fahrenheit. So it's a lot of bang for the buck for a little 5 horsepower, 5-ton chiller. However, it's not an outdoor unit, and it needs to be essentially in a climate-controlled environment that's not going to get colder or hotter than those temperatures I just mentioned. Usually we take 2 or 3 videos, but because this one's cooling so quickly, this is just gonna be a 1 video deal. And like I said, we've been running it for a week. Those 2 little blue lines in there that you see, those go to the new sight glass. The old sight glass was just discolored and it just looked like crap. So I just wanted to wait until that was put on. But what else did we do? Oh yeah, this piping here, there was a tiny leak in the original piping. We tried fixing it, a fitting crack. So all this piping and that blue pipe dope you see right there, that's all brand new too. So again, just an example of some of the things we want to do when we run and test the chiller. Granted, I have to get them out of the shop sometime from a financial perspective. But it's not uncommon. We like to run things for a week or even more. And you always find some little things to fix, and it just makes the startup go that much better, and the customer that much happier. So 9 degrees centigrade is about 48, 47 Fahrenheit if I'm right. And again, when you get below that, you're actually reaching temperatures close to freezing inside the evaporator. So if this customer's running for straight water and we know we want the set point in that range or higher, we just thought that was safe. Again, we can change that if needed. There you go. So it overshoots a little bit for a second, and then it'll wait to go up a full 1 degree centigrade above set point before the unit turns back on. And when the pump always runs, and then it's the compressor and the fans are what cycle based on the temperature control. So again, this is Scott from KIG. Our website is kigsales.com. Thank you.